Okay, today we want to talk about how to find the trig functions or how to write the trig functions of any angle. So far we have only talked about finding the trig functions for the for acute angles, right? So if we have an acute angle triangle like this, we call that angle theta, and then based on that we figure out the sine, cosine, tangent, and all the other three other trig functions, right? So today we want to talk about how can we find or how can we write the trig functions for any angle. In order to do that, we actually set up a circle, and in this circle we consider this as our reference side. We have already talked about that. And then you can think of a terminal side. So let's say this is your terminal side. This terminal side is the side that can move freely across this whole circle. So if the terminal side is in the first quadrant, then you can think of this as a right angle triangle, and this is also called as a reference triangle. This is in the first quadrant. If it's in the first quadrant, it still looks like the triangle that we have seen before, right? It's a simple right triangle. Now, if you have this terminal side in the first quadrant right here, so we like to call this as point P. Any point on this circle will have coordinates x and y, right? So this has coordinates x and y, this point right here, and this distance or this length, or in this case, which is going to be the hypotenuse of the right triangle. But in terms of the circle, what is that called? Yes?
It's called R.
It's called the radius r, yes. So this is the radius r. If this is radius r, so if you just focus on this triangle, which is called the reference triangle, let us label this as point A, point P, and point B. What is the length from A to B? X. What is the length from B to P? Y. Good. So you have this reference triangle in the first quadrant. Based on your previous knowledge about the sine, cosine, and tangent, can we write the sine of angle theta? We usually refer the angles with angle theta. So sine of angle is, remember the SOHCAHTOA? Sine of an angle is opposite over hypotenuse. In this case, the opposite is your y. And what is your hypotenuse?
R.
It's r, so y over r. So instead of always thinking in terms of opposite over hypotenuse and adjacent over hypotenuse, we like to think in terms of x, y, and the radius r. So similarly, can you tell me what would be the cosine for this triangle?
XR.
X divided by r, good. And similarly, the third trig function, which is the tangent of angle, which is in this case would be
Y over X.
y over x. So if we have these three, based on that we can write the opposites of those three, which are, what is the opposite of sine? Cosecant. So cosecant would be r over y. Similarly, what is the opposite of cos? Secant. Secant would be r over x, and then the cotangent would be x over y. Okay? So this was if the terminal side is in the first quadrant. Now we can extend the same definition for this terminal side, whether the terminal side is in the second, so it can, because since it can move around, and the idea here is to look for any angle, not just an acute angle. See, this is less than 90, this is an acute here. We don't know the measure of this angle, but we know it's less than 90, it's supposed to be an acute. But if that terminal side is in the second quadrant right here, instead of this point P being here, if that point is right here, and let us call this point P1 so that we can differentiate. Then we are talking about this whole angle right here. Okay? In that case, the reference triangle would be, if you draw a perpendicular from P1 to this horizontal axis right here, so this would be my reference triangle. Okay, if this is my reference triangle, my point is still going to be x and y, right? But you have to be careful with one thing. In the second quadrant, which is on this side, the x coordinate, would that be positive or negative? It would be negative. And the y coordinate would still be positive. So, but in whether the x is positive or negative, whether it's in the second or the first, the definition is still going to hold true. Okay, this is the same definition that you apply for a point or an angle which is in the second quadrant. Similarly, this could actually move on and be up in the third quadrant right here. The angle increases, it's greater than 180, but you are still going to follow the same definition. You only have to draw a right reference triangle. This is your reference triangle in second quadrant. In the third quadrant, the reference triangle is going to look like this. In the fourth quadrant, the reference triangle again is going to look like this. So it's all about drawing the reference triangles in the proper quadrant and then using the definition. Okay? So can we do an example to illustrate this? Let's go ahead and actually do an example. So I'll keep it right here and let me do an example here which is something like this. We have a point -4 and -3. I have a point -4 and -3, and we want to find the sine, cosine, tangent, and all the other values. Okay? So we need more space, so I'll get rid of this. So if we have to figure out the sine, cosine, and tangent and other values for this point right here, what is the very first thing that you think we have to do? We got to plot the point first. So -4 and -3 is going to be in which quadrant? It's going to be in the third quadrant. -4, so you go left 4 units and down 3 units, somewhere up here. This is -4 and -3. Once you plot the point, what do you think is going to be the next?
Draw the reference triangle.
You have to try to draw the reference triangle, but before I draw the reference triangle, I would start by joining this point to the origin. Let's call this origin. Once you have that, then you can draw the reference triangle. This is 90. You already know 2 pieces of information. This length here, let us call this A, call this point P. You can call it whatever you like, but since we decided to call that point P in the previous cases. So if this is AP, can you tell me the distance between A and origin?
X.
-4.
Negative.
X, in this case that X is
Yeah, negative.
-4. Similarly, what about the vertical length?
-3.
It's -3. Well, remember, length as such is a positive quantity, right? But we want to keep these signs here because when we actually transfer the information into trig functions, these signs are also going to be very important. We have to keep them, right? And then once you have the y, the x value, this right here is the r, right? It's the radius. If you want to draw a whole circle from here, which you may want to draw it, you don't have to draw it. So if you draw a circle, does not look like a circle, but that's what it's supposed to be. So if you draw a circle that goes through this point, then this is the radius r. And how can we find that radius r? Do we have enough information to find that radius? How can we find that radius? This is a right triangle.
Using the Pythagorean.
Using the Pythagorean theorem. So using the Pythagorean theorem, we have r square will be equal to what?
-3
-4.
squared.
You can use -4 or -3, whichever you like. -3 square plus -4 square. And then r square, you can simplify this.
25.
9 plus 16, which is 25. And you have to take the square root of on both sides, which gives you r equals to 5. So r equals to 5. You have the y, you have the x value, and you have the r value. You have all the 3 values that you need to write the sine, cosine, and tangent. So let's go ahead and write the sine of theta. So this angle is theta. Please remember, this whole angle is theta because our terminal side is point -4 and -3, which is supposed to be in the third quadrant. Okay. So this whole angle is theta. Sine of the angle theta is, according to the definition, is what?
Y over R.
y over r. What is the y value here?
Negative 3.
-3. And what is the r?
5.
5. So that takes care of the sine. Then you can write the cosine. It is the x value divided by r, which is -4 divided by 5. And what about the tangent? Tangent is y over x. So y is -3 and x is -4. So tangent would be -3 over -4. What happens to both of these negatives?
They become positive.
They become positive. So tangent is 3/4. This is the tangent. So we have the tangent, we have the other two. So based on this, can we find the opposites of the sine, cosine, and tangent? What is the cosecant? -5/3. Just the reciprocal of the sine. And what about the secant? -5/4. And then you have the cotangent, which is
4/3.
4/3. Any questions about this one? So do you see how we are actually finding the values of the sine, cosine, and other trig functions based on the initial setup? So I'll stop right here today, and then in the next video we'll talk about some different examples.